How do we get the sum of 1 plus 3 plus 5 plus right up to 499? How do we get the square root of this sum? The first thing to do here is to first of all look at 1 plus 3 plus 5 right up to 499. Okay, so we see that 1 plus 3 plus 5 plus 499 is actually a finite sum, a sum of a finite series. Now, what sort of series is this? If we check very well, we see that from 1 to 3, 3 to 5, and so on, there is a common difference of 2. So it is a finite arithmetic progression series with first term 1 and common difference 2. So let us collect our information. Our first term is 1. Our common difference is 2. It is an AP, arithmetic progression. Now, this progression is finite because we know the first term and we know the last term. And we know the formula for the last term. The formula for the last term is the same as the formula for the general term, which is the first term plus n minus 1d. All right. So the last term we know it is 499. So we write 499 is equal to our first term is 1 plus n minus 1. Our common difference is 2. This equation will help us find the total number of terms that are involved in this arithmetic progression. We need to know the total number of terms that are there. We don't have only 1, 2, 3, and then we skip here and come and say 4. There are not only 4 terms. You can see these dots here simply means that we have left out so many terms. How then do we know the total number of terms that are in this arithmetic series? It is by solving this equation. And it came from this formula, which we expect everyone to know. The last term is the same as the general term, and this is the formula for the general term in an arithmetic progression. All right, so let's solve for n in this equation. Let's first of all open this parenthesis. So we have 499 is equal to 1 plus, multiply everything here by this 2. We have 2n minus 2. 1 minus 2 is negative 1. So we have 2n minus 1. If we take this negative 1 from the right-hand side to the left-hand side, it becomes positive 1. So we'll add it here. So this gives us 500 is equal to 2n. Now, if we divide both sides by 2, we're going to see that our number of terms in this arithmetic progression is actually 250. So there are actually 250 terms that have been added up. Now we want to find the square root of that sum. Now that we know the number of terms that are there, the next thing that we'll have to look for will be the sum. We know the sum of an arithmetic progression. We know the formula for the sum of an arithmetic progression. The formula Sn is n all over 2 into 2a plus n minus 1d. All right? Where n is, of course, the number of terms. A, again, is our first term. And d is our common difference. So let's put our values in. N is 250 into 2 multiplied to 1, because our A is 1, plus 250, our N is 250 minus 1 times our common difference. Okay, this is what we get here. So let's create space up here. Let's create space up there. So if we now, let's repeat this statement. We have 250 is equal 250 all over 2 is 250 all over 2 into 2 times 1 is 2 plus 250 250 minus 1 is 249. All of that times 2. Okay, so we have just evaluated this. 250 all over 2, there is it there. Into 2 times 1, that is it. And then 250 minus 1 is 249. Multiply to 2. Now, this should give us our sum. This sum here, we'll call it Sn. We want to get that value. Then later on, we'll get the square root. All right, we want to get that sum. Now, we are dividing everything in here by 2. So that this 2 will cancel here, will cancel there, and will cancel there. So that we'll end up with 250 into, when it cancels here, we'll have 1 plus 249 is equal to the total sum that we're looking for. 249 plus 1 again is 250. So end up with 250 into 250 is equal to that sum there. Now, to get the square root now, we simply take the square root of both sides. Take the square root of both sides. So remember, this is the same as 250 squared, square root. All right, so that the square cancels the square root, and then we'll have our answer to be 250. Okay, so this result here is 250.